The chain rule comes in when there is a function inside of another function. For instance, if we have y is equal to 2x plus 1 raised to the power 10, then 2x plus 1 looks like a function on its own inside of the function y, which has been given to us. So we can say let u equal to 2x plus 1, and therefore y is going to be u raised to the power 10, because now 2x plus 1 is equal to u. So it means in place of 2x plus 1, we can just put u there. Now if this situation happens, it means y is dependent on the function u, and u is also dependent on the function x. This forms a chain, and this brings us to the chain rule. In that case, dy dx is simply the differential of the function y with respect to u. That would be dy du multiplied by the differential of the function u with respect to x. That would be du dx. So in respect of what we have above, y is equal to u raised to the power 10. If you are finding dy du is going to be 10 times u raised to the power 9, and then the differential of u with respect to x, u is 2x plus 1, so we're going to have du dx equal to 2. So by substitution, we are going to have dy dx to be equal to dy du is 10 times u raised to the power 9 multiplying du dx, which is 2. Now after the differential, we can bring our u back. So we're going to have dy dx is equal to 10 times u is 2x plus 1, so we have 2x plus 1 all raised to the power 9 multiplying 2. Then we simplify. So 10 times 2, so dy dx is going to be 20 into bracket 2x plus 1 raised to the power 9. Now if we are casting our mind back, y is equal to 2x plus 1 raised to the power 10, and the differential, which is dy dx, is equal to 10 times 2x plus 1 times 2, with this one raised to the power 9. Now from here you realize that the 2 here is that the differential of what is inside of the bracket here, and the 10 here, the 10 here is the exponent here, and the 9 here is when you subtract 1. Consider the following examples starting from A. So with A, we have y is equal to half x minus 7 all raised to the power 6. Now with this, we want to go through the normal process of the chain rule, and then after that we also talk about the shortcut. With the normal process, we know dy dx is equal to dy du times du dx, and we start that by saying that let u equal to what is inside the bracket, which is half x minus 7, which implies our du dx is going to be half, and then if u is equal to half x minus 7, then we substitute u in place of half x minus 7 in this equation, in the function. So it means that our y is now u raised to the power 6, and if this is differentiated, dy du is equal to 6u raised to the power 5. Now with this, we substitute our dy du into this and also substitute du dx into this. So it means that our differential dy dx is simply 6u raised to the power 5 times the u dx, which is half. Now remember, it's like u was introduced, so we need to get back to the function in terms of x. So we are going to have dy dx is equal to 6 into bracket half x minus 7 all raised to the power 5, then multiplying by half. Now 6 and half are multiplying. 2 go into 6 3 times, so we have dy dx to be 3 into bracket 1 over 2x minus 7 all raised to the power 5. And this is our differential. Now this is going through the normal process with a shortcut. So this is more like a method 2, not like we are taking a different approach. Basically the same thing, but that one is way faster, and that is what you actually need, because when you get to another step in the differentiation, you only have to go through this long process in getting the differential for this simple function. So if we have y is equal to half x minus 7 all raised to the power 6, then our dy dx is very simple. Now the first thing we do is we have to bring this 6 down here. So we're going to write the 6 down. And then the next thing we do is we differentiate what is inside. If you differentiate 1 over 2x minus 7, the result is going to be half. After differentiating what is inside, you don't get it away. You keep it. So I'll write it again. 1 over 2x minus 7. And then I'll subtract 1 from the exponent. That will give me 6. Sorry, that will give me 5. Sorry. Now, from here, half times 6 is 3. So we have 3 multiplying half x minus 7 all raised to the power 5. And your differential is done. Now, let's look at our second example. Here, we are just going to go through the shortcuts. We are not going through the long process. If you want to get through the normal process, you can get the video back and then watch again. So if we have y is equal to 1 over 3 x squared minus 1, and everything is being raised to the power 5, then dy dx is very simple. First, you bring the 5 down, so you have 5, and then you differentiate what is inside of the bracket. If you differentiate what is inside of the bracket, 2 will come and multiply 1 over 3, that will be 2 over 3, then you subtract 1, so that will be 2 over 3 x, because if you subtract 1 from 2, the result is going to be 1. I'm talking about the exponent. And then when you differentiate -1, the result is 0. So that is the end of our differential for what is inside the bracket. And then after the differential, you don't get rid of what is inside the bracket, you keep it. So we are going to have 1 over 3 x squared minus 1 kept, and then we subtract 1 from the exponent of what is inside the bracket, so that will give us 4. Now all we need to do is to simplify this one. This is going to give us 10 over 3x into bracket 1 over 3 x squared minus 4 minus 1 all raised to the power 4. Now remember, you cannot expand this bracket unless you decide to expand the whole of this, probably using binomial expansion because of the power there. So that is B. Now let's go to C. Let's go to the C. C is giving us y is equal to the square root of 4x plus 2. Now, you see, this is not written like a power, or it's not written with something in a bracket with a power. However, it can be rewritten as 4x plus 2 all raised to the power half. Remember, square root means raised to the power half. At the moment you have it this way, then your dy dx becomes, first of all, you bring the half down, that is the power, so you're going to have 1 over 2. Then you differentiate what is inside the bracket. What is inside the bracket is 4x plus 2. The differential of 4x is 4. And the differential of 2 is 0. So that is the end of differential for what is inside the bracket. And then you keep what is inside the bracket, which is 4x plus 2. And then you subtract 1 from the exponent of what is inside the bracket. Half minus 1 is negative half. Then after that, you simplify your answer. So we have dy dx is equal to half times 2 is 2 times, because this is a power, a negative power, we need to rewrite it. Please remember, when the question is given to you and it is written in terms of square root, if your final answer is possible, try to write it in that way. So don't leave your answer in raising to the power negative half. So what I have there, 4x plus 2 all raised to the power negative half, is going to be 1 over 4x plus 2 all raised to the power positive half. Remember the laws of indices that we've talked about. Now dy dx is equal to 2 times 1, that is 2, all divided by, half can be written as square root, so we have square root of 4x plus 2. So this is the end of our differential. So that is it. Now let's go to the last one, which is D, and end the topic. D is giving us y is equal to 1 over 2x minus 3 all raised to the power 2. Now if you have it this way, you have to rewrite this one, which is going to give us y is equal to 2x minus 3 all raised to the power negative 2, so that it will look like how we started. So it means dy dx is equal to, bring this down, so we have negative 2. We differentiate what is inside the bracket, which is 2, and then you take 1, in fact you keep what is inside the bracket, that will be 2x minus 3, and then you subtract 1 from the exponent, that will give us negative 3. Negative 2 minus 1 is negative 3. Then you simplify your answer. So it means dy dx is going to be negative 4 multiplying 2x minus 3 all raised to the power negative 3. And then, like I said, when a function is given to you in this form, you have no business keeping your answer this way, especially when it is raised to the power negative 3. So keep your answer like it was given to you. So it means you're going to have dy dx to be equal to negative 4 raised to the power, or divided by 2x minus 3 all raised to the power positive 3. And that is your final differential.